Our team examined the UNH Woodlands and agricultural operations as natural climate solutions. My name is Luke Howard, and I'm a political science and sustainability dual major with a business minor.
I'm Sydney Marshall. I'm a finance and sustainability dual major.
I'm Mikey Pasciuto. I'm a mechanical engineering and sustainability dual major.
And I'm Luke Zuchowski. I'm environmental engineering and sustainability dual major.
So our team focused on woodlands and agriculture operations as natural climate solutions under the mentorship of Dr. John Gunn, who is a professor of forest management at UNH. As climate change effects are becoming more and more prevalent locally and globally, there are certain industries to focus on that can be large contributors, but also have the capacity to help reverse these effects, specifically related to greenhouse gas emissions. With such a vast area of local land being managed by UNH, there's an ample opportunity to investigate changes and practices to provide sustainable solutions. And the main approach that our team used was to quantify current GHG sources, which are emissions in the atmosphere, and sinks, which are removals from the atmosphere on UNH farm and woodlands. After creating this baseline, the team can identify changes that could provide meaningful, cost-effective improvements to the GHG emissions profile of the university, as well as alternative land management practices.
So for the methods for the forestry, we used existing forest management plans combined with the 4-gate spreadsheet tool, which will essentially estimate CO2 and other greenhouse gas emission sinks and sources. We were able to test numerous scenarios based on the potential management practices. So it allowed us to be much more flexible and test a few different things. And with the farms, we conducted interviews with the farm managers, and we wanted to establish a connection there so we could see historical practices and present practices. We established field management practices, livestock, energy, those sources as well. And it was through Comet Farm, which is a tool similar to 4-gate, but for the farm side of things, we were able to come up with analyses and recommendations.
So we found that there's been a significant improvement in and lowering of the carbon footprint of UNH's agricultural practices from the 1980s to present day. The farmlands we examined had inherent carbon capture with the use of forestry, as a number had a significant or a majority of the acreage dedicated to forestry stands. Most of the farms had relatively small carbon capture due to their horticultural or agricultural crop activity. And there's room for continued improvement through integration of more regenerative agricultural practices, such as a decreased use of synthetic chemicals or uncomposted material, which would have less of a direct impact on the carbon and more on other greenhouse gases, such as methane and N2O. Further use of cover cropping, which would increase crop-focused carbon sinks, and integration of vermicomposting to speed up the storage of carbon through composting. And as far as carbon credit generation goes, other than that which the forestry stands provide, there's potential for a biogas or heat storage facility in combination with the composting and dairy programs on campus.
The outputs from the 4-gate tool can be seen here on the right. The columns represent the time frame, while the rows represent the wood type and use. And as you can see at the bottom of the data table, based on existing conditions and management practices, the UNH woodlands are able to sequester approximately 48,000 tons of CO2 every 10 years. And we suspect that these numbers could be improved if management practices are altered. Implementing a carbon offset program would increase the volume of carbon sequestered. This would mean an increase in the number of trees selectively harvested, as well as an increase in partial harvests in the UNH woodlands. The green line in the graph at the bottom right-hand corner represents the amount of excess carbon that could be sequestered if a program like this were to be implemented. As you can see, this could mean up to an excess of 200,000 tons of CO2 sequestered over a 150-year period.
So in conclusion, we determined there's significant potential for a carbon offset program at UNH, whether it's strictly forest or farm or a combination of the two. Through the forest, we're able to see a reserve/hybrid selection method would be the best scenario. It would sequester the most carbon. And also this would come with the management of invasive species to ensure that you're only harvesting lumber and other long life cycle products, because Even if you're using a selection or reserve scenario, if you're cutting down trees at their infancy and not producing long life cycle products, it will only emit carbon. And an increased integration of regenerative agriculture and the significant potential for biogas or heat storage, which require large investment, are ideal for the farms. And with that, thank you very much for listening today, and we'll take questions in a few minutes.